Alright, so you remember from chapter 2 that P implies Q means if P then Q. So a negation of a statement is not the statement, so not P. Or in symbols it looks like this, not P. That symbol means not. In the inverse, well, if you remember that the converse, if Q then P, the inverse is not P implies not Q. Sometimes you'll see it. This is a way to write it not. It also is like this. Not P implies not Q. Actually, I think our book uses the squiggly line, so I'm going to stick with the squiggly. So an inverse is just basically put nots in front of both statements, both the hypothesis and the conclusion. The contrapositive is not only do you do nots, but you switch the P and the Q around. So it's not Q implies not P. Or you write it as not Q implies not P. So here it is with an example. So if the conditional statement is, if a figure is a square, then it is a rectangle. The negation of the hypothesis is, look at the hypothesis, a figure is a square. The negation is a figure is not a square. The negation of the conclusion, if this is the conclusion, the negation of it is not a rectangle. And then if I write the inverse, if I have the conditional as if a figure is a square, then it is a rectangle. My inverse would be if the figure is not a square, then it's not a rectangle. And the contrapositive is flip it backwards. So write if it is not, if the figure is not a rectangle, then it's not a square. So contrapositive, what I remember is it's the longest word. It makes the most complicated thing. Now the law of the contrapositive reads that the conditional is true, then the contrapositive is true. If the conditional is true, then the contrapositive is true. And it also goes backwards. If the contrapositive is true, then the conditional is true. Same thing with false. If basically the truth value matches up with the contrapositive and conditional. So if you know the contrapositive is true, then the conditional is true. If you know the conditional is true, the contrapositive is true. And down here, here's another example. So if a triangle ABC is equilateral, then it is isosceles. The converse from chapter 2 is if the triangle is isosceles, then it's equilateral. That we know the converse is not true. Now let's write the inverse. If triangle ABC is not equilateral, then it's not isosceles. And the contrapositive is if it's not isosceles, then it's not equilateral. My handwriting's horrible. Then it's not equilateral. So which statement above is true? If a triangle ABC is equilateral, then it's isosceles. So definition of isosceles in some books is that it has two or more sides equal. So if the conditional is true, because if it's equilateral, then it automatically has two or more sides equal. So we know that the conditional is true. As soon as we know the conditional is true, then we know the contrapositive is true. And the second part of the section is indirect reasoning. So in indirect reasoning, all possibilities are considered. When you prove every other statement is false, the remaining possibility must be true. So for example, let's say you have these three situations, A, B, and C. So either A is true, B is true, or C is true. They can't all be true. So indirect reasoning is proving this is false and this is false, so therefore the answer must be C. That's indirect reasoning. It's kind of like taking a multiple choice test and then crossing off all the possible ones and just it leaves you with the right answer. So in an indirect proof, a statement and its negation are the only possibilities. So when you write an indirect proof, you have to state the opposite of what you want to prove. So here's the first example. Prove that a triangle cannot contain two right angles. So my step one is going to be triangle ABC has or contains two right angles. So now I'm going to read through and show that there's a contradiction or it doesn't work. So if triangle ABC has two right angles, that means that, but we know that means, let's call the measure of angle A is 90 and the measure of angle B is 90. So in the triangle, the measure of angle A plus the measure of angle B plus the measure of angle C we know has to equal 180 degrees by the triangle sum theorem. But if this is 90 plus 90, that cannot, plus another angle, cannot be equal to 180. This is my contradiction. So at the end I write therefore, so I point out my contradiction, which is in red, therefore, and I go back to my original statement. A triangle cannot have two right angles. Okay, and the second one, so the first step is to write the negation. So it says, prove that triangle ABC cannot contain two obtuse angles. So we're going to write that triangle ABC contains two right angles. So, or not two right angles, two obtuse angles. Let me erase this up here. Obtuse. So the measure of angle A is greater than 90 and the measure of angle B is greater than 90. So again, 90 or greater plus 90 or greater plus angle C cannot equal 180. So then my last line, so I always have to state the negation. Then I logically go through until I have a contradiction. My contradiction is red. And then at the end I write, therefore, triangle ABC cannot have two obtuse angles. All right, down here. Identify the statements that contradict each other. So two of these statements are going to contradict each other. These should all have segment bars, by the way. So FG is parallel to KL. So FG parallel to KL. B, FG perpendicular to KL. FG congruent to KL. So they could be congruent like this, they could be congruent like this. So which ones contradict each other? You cannot have something be congruent and or parallel and perpendicular at the same time. So those are the two statements I'm going to circle that contradict each other. And then the last one, write the first step of the indirect proof. It is snowing outside. So the first step of an indirect proof is always the negation. So it is not snowing outside.